A pleasant day to everyone. I am delighted to have this opportunity to share with you some insights about our DOST-MOST joint research program titled The Development of High Performance and Low Cost Membrane Electrode Assembly for Alkaline Fuel Cell based on ion-electron dual conducting catalyst layers. This is a collaborative work by the Department of Mining, Metallurgical and Materials Engineering of the University of the Philippines, Diliman, with the School of Material Science and Engineering of Hefei University of Technology in China. Renewable energy is a common concern and is a priority area in this joint research program between China and the Philippines. A lucrative strategy for renewable energy self-sufficiency is the adoption of fuel cell technology. Fuel cell membrane electrode assembly research requires multi-party cooperation to achieve simultaneous breakthroughs in materials and manufacturing processes. Furthermore, there is an urgent shortage of manpower in the field of fuel cell technology, and it is necessary to train talents to comprise a high-level fuel cell materials R&D team. The Philippines boasts of its expertise on fuel cell membrane preparation via radiation grafting method. However, lacks the platform for comprehensive performance assessment in cell stack modules. On the other hand, our Chinese partners have established expertise on electrocatalysis and optimized design of membrane electrode assemblies. However, they lack a stable supply of high-performance and low-cost fuel cell membranes. Such complementarity is essential for this research collaboration. The following are our research objectives. 1. To use radiation grafting technology to introduce ion transporting groups on cellulose-based precursor materials to produce anion exchange membranes. 2. To construct ion-electron double conduction support by controlling the surface structure of carrier materials with non-precious metal oxygen reduction-based catalyst. And lastly, to assemble efficient, low-cost anion exchange membrane fuel cell and establish a material performance evaluation system based on single cell and fuel cell stack. So how does a fuel cell work? A fuel cell is an electrochemical device that converts chemical energy from fuel into electric current. The animation shows the cross-section of a proton exchange membrane fuel cell. Here, you have the anode on the left side, while the cathode is on the right. Sandwiched between the electrodes is the fuel cell membrane. The membrane serves as the medium where protons, or OH ions in the case of an ion exchange membrane, are transported in between electrodes. The process starts by feeding hydrogen fuel through the anode, wherein hydrogen splits to protons and electrons through electrochemical interaction with the catalyst layer. The proton then travels through the membrane, while the electron passes through the external circuit that powers our load. The proton then meets the oxidant in the cathode side, forming water in the process with corresponding release of heat. In this project, high-performance membrane preparation involves the actual synthesis, subsequent characterization, and degradation and stability assessment. In the membrane fabrication, the irradiation facility of the Philippine Nuclear Research Institute is being utilized, as it hosts both gamma radiation and electron beam source. The gamma irradiation process enables the grafting of a suitable monomer to a cellulose-based polymer backbone. Subsequent functionalization of the radiation-grafted copolymer enables it to conduct ions. Several types of low-cost, locally available cellulose resource will be utilized for the membrane fabrication. It is envisioned that lowering the cost of fuel cell membrane component will effectively cascade to reduced cost of developing fuel cell infrastructure. Lastly, we endeavor to meet and obtain the following targets and figures of merit to ensure that our membranes are comparable with commercially available membranes in terms of performance. Thank you very much.